We have two resistors in parallel. We're trying to work out their combination of resistance. So we can use the resistors in parallel equation for this. 1 over RT, 1 over R1 plus 1 over R2. That gives us 1 over 72. And then we can flip both sides of this fraction. And then we end up with RT is 72, which is about 70 ohms. For part B, we're told that the cell has an internal resistance, so let's draw that on. We're given the EMF and the internal resistance, so 9 volts, 2.5 ohms, and we're trying to work out the energy dissipated in the resistor combination specifically. So we're trying to work out the energy dissipated in these two, and there's a few ways that we can do this. I'm going to work out the current in the circuit, and once I have the current, I'm then going to use the equation P is equal to I squared R with the resistance specifically that we have here to work out the power dissipated, and then I can use the equation energy is power times time to then work out the energy dissipated in 5 minutes. So yeah, we have T. T is 5 minutes, or this many seconds. So to work out the current, we can do the EMF divided by the total resistance. The total resistance is 72, which is what we worked out for the combination of the two resistors earlier. So then that plus the internal resistance, because the internal resistance is in series with these two. And if you're not sure as to how this is in series with these two, you can rewrite the circuit like this, or redraw the circuit like this. So here is your cell. Here are the two resistors that are in parallel. And then I'm going to put the internal resistance here. And this is no different to what we have on the left-hand side. I've just moved this component to down there. So there's no difference. And now you can hopefully see a bit more clearly that the internal resistance, so that is the 2.5 ohms, that is in series with these two. These two are in parallel, but then those two are in series with a 2.5 ohm resistor. So then yeah, if you wanted to work out the total resistance of these three, then you would add up the resistance of the two in parallel with the internal resistance, so 72 plus 2.5. And so we know that the EMF is 9 volts, so 9 over 74.5. So divide the two things, and we end up with 0.12081 amps. Now we can work out power. Power is I squared R, so 0.12081 squared times specifically the resistance of these two, because we're trying to work out the power dissipated across them. So that would be 72. And we get our power to be 1.05076. And now we multiply our power by time, so 1.05076 multiplied by 5 times 60, and we end up with 315 joules, which will be our answer.